Hello everyone! This video is about solving logarithmic equations. So let's start with the first one. What is the value of x at logarithm of 2x plus 4 to the base 5 equals 2? So first of all is to change this into exponential form. So that would be 5 squared equals 2x plus 4. So 5 squared is 25 equals 2x plus 4, and then transpose 4. So that would be 25 minus 4 is equal to 2x. 25 minus 4 is 21 equals 2x. Divide both sides by 2 to solve for x. Therefore, x is equal to 21 over 2. Number 2, logarithm of x is equal to 1 minus the logarithm of x minus 3. Since the base is not given, so it means that the base is equal to 10. And we also have two logarithms on both sides of the equation, so we're going to combine them into single logarithm. So that would be the logarithm of x plus the logarithm of x minus 3 is equal to 1. And recall the laws of logarithm. If it's plus, it means that's the product law. So that's the logarithm of x times the logarithm of x minus 3 equals 1. So now it's transformed to single logarithm. So we can now change this to exponential form. Of course, it's base 10. Okay. So that would be base 10 raised to 1 is equal to x times x minus 3. So that's 10 is equal to x squared minus 3x. So let's combine them and equate it into 0. So we have x squared minus 3x minus 10 equals 0. So this is a quadratic equation that we can solve by factoring. So this is x minus 5 plus 2. So the values for x is x equals 5 and x is equal to negative 2. Since we have two values of x, we should check them both. So let's start with x is equal to 5. So let's substitute that with our original equation. So that's logarithm of 5 is equal to 1 minus the logarithm of 5 minus 3. So logarithm of 5 is equal to 1 minus logarithm of 2. Since there's no negative numbers or zeros logarithm, therefore x equals 5 is a solution to this problem. Now let's check x is equal to negative 2. So logarithm of negative 2 is equal to 1 minus the logarithm of negative 2 minus 3. So this is logarithm of negative 2 is equal to 1 minus logarithm of negative 5. Since we have negative numbers or negative zeros in the logarithms, so x equals 2 is not a solution. So we only have one value of x or one solution, and that's equal to 5. Next, we have logarithm of x squared minus 6x to the base 2 is equal to 3 plus logarithm of 1 minus x to the base 2. So again, we have two logarithms on both sides of the equation. So let's combine them. Let's put this equation into single logarithm. Okay, so let's transpose this logarithm to the other side. So that would become logarithm of x squared minus 6x base 2 minus the logarithm of 1 minus x to the base 2 is equal to 3. Recall the quotient law of logarithms. So if it's minus, it means division. So logarithm of x squared minus 6x over 1 minus x to the base 2 is equal to 3. So now it's in single logarithm. We can change this to exponential forms. So that would be 2 cubed is equal to x squared minus 6x over 1 minus x. 2 cubed is 8 is equal to x squared minus 6x over 1 minus x. Let's simplify. Multiply both sides by 1 minus x. Okay, or cross multiply. So you will have 8 times 1 minus x is equal to x squared minus 6x. And then let's combine everything and equate to 0. So this would be 8 minus 8x is equal to x squared minus 6x. So x squared minus 6x plus 8x minus 8 equals 0. Okay, so let's combine this. So we have x squared plus 2x minus 8 equals 0. So again, we have quadratic equation. We can find the zeros by factoring. So this would be x plus 4 and x minus 2. So again, we have two values of x. One is negative 4 and one is positive 2. So we need to check whether these two values of x are solution of this problem. Let's start with x equals negative 4 and substitute this to the original equation. So logarithm of base 2, so that's 4 negative 4 squared minus 6 times negative 4 is equal to 3 plus logarithm of 1 minus negative 4 to the base 2. So this would be logarithm of 16 plus 24 to the base 2 is equal to 3 plus logarithm of 1 plus 4 is 5 to the base 2. So we can see that we have positive logarithms, positive 0. So therefore, x equals negative 4 is a solution. Now let's check x is equal to 2. So substitute to the original equation. So that would be 2 squared minus 6 times 2 to the base 2 is equal to 3 plus logarithm of 1 minus 2 to the base 2. So we have logarithm of 4 minus 12, that's negative 8 to the base 2 is equal to 3 plus logarithm of negative 1 to the base 2. So we have negative zeros, negative numbers. That's not a potential, or that's not a possible solution. So we only have x equals negative 4. Let's have this. ln of 3x minus 2 equals 5. So ln is natural logarithm with the base e. So let's change this to exponential. So this would be e raised to the 5th power is equal to 3x minus 2. So let's transpose negative 2, or we add 2 on both sides. So that would be e to the 5th plus 2 is equal to 3x. And then divide both sides by 3 to solve for x. So x is equal to e raised to the 5th power plus 2 over 3. Then using our calculator, this is equal to, or approximately equal to 50.14. Last one, we have ln of 10 minus ln of 7 minus x equals ln of x. So we have logarithm or natural logarithm both sides, so we will combine all of these into single logarithm, and then we'll just drop the logarithm afterwards to solve for x. So this would be ln of 10 divided by, because it's minus, quotient law, remember, over 7 minus x is equal to ln of x. And then we can drop ln on both sides. So we'll have 10 over 7 minus x is equal to x. And then let's cross multiply. So this will be 10 is equal to x times 7 minus x. So 10 is equal to 7x minus x squared. So let's equate this to 0. So this would be x squared minus 7x plus 10 equals 0. So we have a quadratic equation that we can solve the values of x by factoring. So that is minus 5 and minus 2. So we have x is equal to 5 and x is equal to 2. And since we have two values of x, we'll check if both of them are possible solutions. So let's start with x equals 5. Substitute to our original equation. So that's ln of 10 minus ln of 7 minus 5 is equal to ln of 5. So 7 minus 5 will be ln of 2. So ln of 10. So since they all have positive numbers, no negative zeros, so this is a possible solution. Now let's try x is equal to 2. So ln of 10 minus ln of 7 minus 2 is equal to ln of 2. So ln of 10 minus ln of 5 is equal to ln of 2. And since we also don't have negative logarithms, so x equals 2 is also a possible solution.